Hello everyone. Welcome to this case study presentation on a very interesting and unique topic, how Google uses finite automata in search engine optimization. I am SD Karthikesh, and today we are going to explore how a core concept from the theory of computation, finite automata, plays a silent yet powerful role in one of the most advanced technologies we use every day, Google search. While this may seem like a purely academic concept at first glance, I promise you will be surprised to see how theory meets application here. So let's dive in. Let's begin with a quick overview of what finite automata is. In the world of theoretical computer science, finite automata, often abbreviated as FA, is a computational model used to represent and recognize regular languages. It consists of states and transitions and is widely used in lexical analysis, pattern recognition, and text processing. Now, why are we talking about this in the context of Google? Because Google's search engine is all about processing massive amounts of textual data, and Infinite Automata is the silent workhorse that makes this possible efficiently. This case study will explore how finite automata underlies Google's web crawling, indexing, and even early stage filtering. We will also understand the relationship between theory of computation and real world applications, especially in digital marketing and search engine optimization. What is search engine optimization and how Google works? Search engine optimization or SEO is the process of improving the quality and quantity of website traffic by increasing the visibility of a website to users of a search engine. Google does this using bots called Google bots, which are essentially automated software agents that crawl billions of web pages across the internet. These bots read and analyze the content of websites to determine what a page is about. But how do they understand the structure of a web page, extract meaningful information, and store it in an organized form? That's where pattern recognition comes in. And that's where finite automata enters the picture. Finite automata in web crawling. Googlebot works by reading the HTML code of a web page. Think of it like reading the behind the scenes script of a website. It identifies components like titles, headings, paragraphs, links, and meta tags, and many more. Each of these components follows a predictable structure or pattern, and that's what finite automata excels at, recognizing patterns. For example, when identifying a tag, the crawler can use a deterministic finite automaton to recognize the exact string pattern and extract the heading. It's quick, reliable, and memory efficient. This makes finite automata ideal for massive scale crawling where speed and precision are essential. Pattern matching with finite automata. Pattern matching is where finite automata really shines. Let's consider regular expressions or regex, which are often used for searching and extracting data. At the core of every regex engine, there is a finite automata. Whether it's finding all email addresses on a page or locating keywords, the underlying mission is essentially a finite automaton scanning the input characters and transitioning through states. This allows Google crawlers to quickly identify specific content and ignore irrelevant text, streamlining the crawling and indexing process. Regular expressions or regex is the practical implementation of finite automata. It is used for searching strings like emails, keywords, and phrases. Now, let's do a case study on the query processing in Google search engine. Let's say a user types cheap phone under 10,000 into the Google search bar. What happens next? The query is first broken down into tokens. Tokens are actually words like cheap, phone, under, and 10,000. These tokens are matched against billions of entries in Google's index using finite automata based filters. This allows Google to quickly eliminate irrelevant results and shortlist the pages containing the matching terms. This happens in milliseconds. The finite automata here works like a sieve, passing through only those documents that satisfy the regular patterns rules. What's amazing is how such a basic computational model plays a vital role in one of the most complex search engines on earth. So, the finite automata here is used to match words across billions of documents, and later ranking algorithms are applied. Here we have the image of a finite automata. There is an input tape which contains the input characters. The input characters are fed into the finite automata. The finite automata here contains finite number of states such as Q1, Q2, Q3 up to Qn, where n is a finite number. After the finite automata processes each character, it gives the output in the output tape. This is the Google bot. The Google bot is a web crawler used by Google. The purpose of the Google bot web crawler is to analyze each content so that we can find whether the keywords are present in the web page or not. This image shows how a Google bot crawler works. Now, let us see why the Google search engine uses finite automata and not more complex models. You might be wondering why not use more advanced models like Turing machines or push down automata. Well, it's all about the trade offs. While more complex models can handle a wider range of problems, they are also slower and require more resources. Finite automata are fast, consume low memory, and operate in linear time, making them perfect for real time applications like web crawling and pattern matching. Especially during the initial stages of query processing and content crawling, Finite Automata is the most efficient tool in the toolbox. Finite Automata is fast and memory efficient. It is ideal for initial stages of search pipeline and it is suitable for regular expression matching. Now, let us talk about the benefits in the SEO optimization. The Finite Automata directly contributes to the search engine optimization. Google uses Finite Automata to detect bad SEO practices like keyword stuffing, repeating the same word unnaturally many times. It can also identify structured data and metadata which follow regular patterns. Finite automata is also used in validating sitemaps, URL formats, and even detecting spammy content. These processes not only help Google index content better, but also ensure users get high quality, relevant search results. Now, let me explain why I've chosen this topic. This topic is truly unique because it brings together two seemingly different worlds, the theory of computation and digital marketing. Most students treat TOC as purely academic and disconnected from real world applications. But this case study shows otherwise. It's a great example of how deep theoretical foundations silently power some of the most practical and widely used technologies today. Understanding this connection not only strengthens our grasp of the subject but also prepares us for applying these ideas in innovative ways. It bridges the academic theory and real world systems. It demonstrates the power of theoretical knowledge and practice and provides valuable information. Now, we have come to the conclusion. To sum up, Finite Automata plays a key role in how Google works, especially in the early stages of crawling, indexing, and filtering. It's simple, efficient, and highly effective. While we often focus on high level algorithms and artificial intelligence models, It's important not to overlook the fundamental concepts that enable these systems to function. So, next time you type something into Google search, remember that a tiny but mighty finite automata is already working behind the scenes to help deliver those results. The Finite Automata powers early stage filtering in Google search. It provides a fast and scalable way to handle huge data. So, thank you so much for listening. I hope this presentation gave you a fresh perspective on the real world relevance of theory of computation, and especially how finite automata silently powers the digital world around us. I'd be happy to answer any questions or hear your thoughts. Thank you.